Good afternoon. This is the AAT for data science. Here we have done an image classification of dogs versus cats using convolutional neural networks. Image classification is one of the fundamental tasks of computer vision and data science. Cats versus dog classification is a popular problem that showcases the capability of CNN in distinguishing between different classes of images. And this also has practical applications in areas such as animal recognition, pet adoption platforms, and automated surveillance systems. In this cat versus dog classification problem, the main goal here was to develop a model using CNN that can accurately distinguish between the images of cats and dogs. This task showcases the capability of CNN in handling tasks also. For this, the data sets that we have used for training and testing consists of around approximately 20,000 pictures, and they were taken from Kaggle. The classes that we have here used to segregate are dogs and cats. Convolutional neural networks, or CNN. Here, they are a class of deep learning module commonly used for image classification recognition tasks. They are specifically designed to process data with grid-like topology, such as images, by applying series of convolution filters. Here we can see the image here is of a cat, and these are the amount of convolution layers that are applied, the pooling layers, and they are totally connected, and output is predicted if it's a cat or a dog. Here, data processing. Here, in this program, we have our data was mainly processed the data from Kaggle was put in a zip file, and it was later extracted, and validation through training and generator models. Here the image is resized to 256 into 256 pixels, normalizing ends by normalizing. After all of these layers, we get the output. Model architecture. This was the main model architecture that we used. The input layer was usually to the model 256 into 256 into 3 and RGB image. So for this, we had to resize the image many a times. And these were mainly the convolution layers and other details of what we have used. We have even used a flatten layer to flatten the images so that it is easier and more accurate. Training results, and we have plotted numerous line plots showing various parameters over the epoch. Over 10 epoches we have done to gain more accuracy. Model evaluation. The model was trained with the data that from the test and the training sets, and when given an unknown or a unused data or a new data to the model, it predicted correctly. Here this was the input of dog that was given, and the output was given as a dog, and this was also correctly identified. Conclusion, and here now going, we coded this in I coded this in here the first code cell is used to create a directory and a copy of Kaggle API to the file to read it to the proper location. And here the code downloads dogs versus cats dataset from Kaggle and extracts it. And this is used to extract the data from this into the test and the train data shown here. And this is TensorFlow. Here, importing necessary libraries such as TensorFlow, Keras, and these required layers were mainly imported so that image processing could be done. And these are the generators or the trainers. Here the code sets up data generators using image data set from directory function to load the preprocessors and train the validation images. The images are resized to 256 into 256 and then normalized to values between 0 and 1. In this, here once this was done, we found out that there were 20,000 files belonging to two classes and 5,000 files belonging to two classes. That was these 22,000 were in test, and the train were in 5,000 files belonging to two classes. These files contained pictures of dogs and cats that we used to train the model with. Here we are normalizing the data. And this is the CNN model that we have used. The model is created using a sequential API from Keras. It consists of several con 2D layers followed by batch normalization, max pooling 2D, and dense layers. The last layer using sigmoid activation or binary classification is added here. Here the model is compiled and the summary is given with and here we have used Adam optimizer, binary cross entropy loss, and accuracy metric. The training is performed for 10 here the training is to measure the accuracy. Here we have trained it for 10 approaches. And as we can see here, in the first approach, we got about an accuracy of 50%, later increased to 65, following 69, 73, and 73.4, 77, 78, 79, and 74. Through this, we found out that at each instant, the accuracy of the model increased. These were some of the basic plots that we could plot to find out the training and the validation. Here, the more number of training that we have done here, the accuracy, that is the red line, has increased. The code using MATLAB to plot the training and validation accuracy and loss curves. Here, the after the first trial or the first approach, the validation or the accuracy remains somewhat constant, and less distance between these two curves shows that the model is not overfitted. Similarly, here also, loss we can see is very much minimal and is reduced over the time of over the number of approaches that we have used. Here, now to test a new this was to test the model, and now we are trying with the unused data to see how the model performs. Here we have put import CV2 to basically import the hi. And here we've imported the dog picture. This picture was not there in the previously trained data set. Hence, this is a new picture. And this picture is this picture's shape is around 1400. This is quite high and this cannot be done. So we have resized this to 255, 256, 256. And then the model prediction is the model predicts array 1, and array 1 here means the model is predicted dog. Hence, successfully this was done. Hence, we could find out the output for the given photos by training the model. Thank you.